right, everybody, we are going to be going over lesson 7.5. So this is our last lesson that is in this system of equations unit, right? So we've done solving by graphing, we've done solving by substitution, we've done solving by elimination, and then now we're kind of doing like the special types. Now, the cool thing is that we've kind of already learned this. So we dabbled in this in graphing, and we dabbled in this in 7.22. So this should kind of actually be pretty easy and kind of a refresher. And if it's not, that's perfectly okay. That's why we're going to have a lesson over it too. Now, if the background noise is a little loud, I'm sorry. The air conditioning is still on in the classroom, so I can't really turn it off. So I'm going to try my best. I might try to put some editing skills into use to block it out. But we're going to continue. So we have talked about when we solve a linear system, we have an answer, right? And our answer is always written as an ordered pair. But sometimes linear systems can have no solution. Oops. Or they can have infinitely many solutions. And we've kind of talked about that already, right? Because we talked about, well, if a system doesn't have a solution, then the lines don't intercept, because the whole way that a linear system has a solution is at the point of intercept. So if they don't have a point of intercept, there's no solution. And if they have as many as you can think, well, they're the same line, right? So they have many, many points of intercept. So we'll get more into it, but that should kind of make sense if you're picturing it in your head. So first one we're going to talk about is when a system has no solution, right? So a linear system has no solution when the graphs of the equation are parallel. And that makes sense because if, again, the lines aren't crossing, the lines are parallel. So what we call this is when a system has no solution, it's called an inconsistent system. Inconsistent system. Which you would guess then when we have infinitely many solutions, that's called consistent. So, recap, no solution, lines are parallel, inconsistent, okay? So let's practice. Right here we have these two equations, right? And it looks like they're in standard form. Now, I'm not going to take the time to graph in standard form, right? I'm not going to plug in 0 for x to get y, and then I'm not going to do all that. So what I'm going to do is I'm going to put them into slope-intercept form. Now, we've already talked about slope-intercept form, remember, which is y equals mx plus b. For me, that's the easiest way to graph. So we're going to do that. So we have 3x plus 2y equals 10. Okay, right off the bat, I know we are going to have to move our 3x over to the right side. So the opposite, or the inverse of positive 3x, is negative 3x. And remember, you need to do that on both sides of your equation. And when you do that, then you should get 2y equals negative 3x plus 10. Now remember, we can't have our y being multiplied by anything, right? We can't have it. We got to have y by itself. So in order to get y by itself, because this is technically 2y, so 2 times y, we are going to have to divide everything by 2. Right? Okay, when we do that, our new equation is going to be y equals negative 3 over 2x plus 5. Now, we can totally graph this line now. So I'm going to do it in purple. So I'll just do first equation in purple. So I see that my y-intercept is 5. So I'm going to go up 1, 2, 3, 4, 5 on the y-axis. And then it looks like my slope is negative 3 over 2. So if my slope is negative 3 over 2, that means I'm going to go down 3 and to the right 2. So I'm starting at my point of intercept on the y-axis, so I'm going to go down 3, 1, 2, 3, and over 2. I'm going to do the same again, so down 3, 1, 2, 3, and over 2. 1, 2, 3, over 2. And then I'm going to draw my line. Okay, so we have the first linear equation graphed. We need to graph the second one now, right? So same thing, this needs to be in y equals mx plus b. So first thing we need to do is move that 3x to the right side of the equation. So we're going to subtract 3x from both sides because we have to keep our equation balanced, which would give me 2y equals negative 3x plus 2. All right, it looks like my y is still connected to 2 by multiplication. So we're going to have to divide everything by 2. And when you do that, you're going to get y equals negative 3 over 2x plus 1. And I'll graph this one in orange. Okay, so it looks like my y-intercept is at 1. So we're going to put a point at 1 in the y-axis. And my slope again is negative 3 over 2. So I'm going to go down 3 and to the right 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, now I'm going to do 1 point going the inverse way, right? Because a line doesn't just go one way, it goes the other way. So now I'm going to go up 3. 1, 2, 3, and to the left 2. 1, 2. Okay, so at this point now, you should have 2 lines on your graph. And there's a couple things I want you to pay attention to. These lines are parallel, right? They're going to go on forever and ever and ever, and they're never going to touch. So they have no solution. There is no point of intercept. Now, I want you to look at the 2 linear equations. And I want you to kind of think, what is similar? Because you're going to notice their slope is exactly the same. So just a little heads up, we can write it off to the side, right? Important info, that if you have parallel lines, right? If you have lines with no solution, the slope is the same, but the y-intercept is different, right? Because if the y-intercept and the slope was the same, they would just be the exact same line. So parallel lines, the slope is the same. Hold on, that kind of looks like negative slope. I don't want you to get confused. So the slope is the same, but the y-intercept is different, okay? Now, I'm going to show you 2 ways to solve. We're also going to be solving by elimination. So we did graphing, now we're going to do elimination, okay? So let's just rewrite our equations again so we don't get confused. We have 3x plus 2y equals 10, and then we also have 3x plus 2y equals 2. Okay, so remember when we're solving by elimination, we are trying to get rid of an x variable or a y variable. In order to do that, we need to see if something is the same or if something's different, right? And it looks like 3x and 3x are the same, but it also looks like 2y and 2y are the same. And we are going to solve by subtraction, right? Now, usually when we do elimination, we are just canceling one variable, right? Because then we're solving for the other. In this case, though, it canceled both. So do we have a variable to solve for? No, it's not x equals 8 or y equals 8. Nothing equals 8. So we have no solution. All right, I want you to try to do this one on your own. So right now I want you to pause the video. I want you to try it on your own, right? Because in math, we learn by doing, and it's okay to make mistakes. So I want you to try it by yourself. Then I want you to play the video and check your answer. Alrighty. So again, remember, we're going to be graphing, and the easiest way to graph is by graphing something in slope-intercept form, which is y equals mx plus b. So first thing you should have done is move the 2x to the right side of the equal sign. And to do that, I'm going to have to subtract by 2x on both sides to keep my equation balanced. Once you've done that, you should have gotten 2y equals negative 2x minus 6. And you can't have y being multiplied by 2. So then you needed to divide every single term in your equation by 2. And when you do that, you should have gotten y equals negative 1x minus 3. Here, I'll write it right here too. All right, I'm going to put this in light green so we remember. All right, so my next equation, it looks like is 2x plus 2y equals 4. Okay, so we should have done the same thing again, right? We need to move 2x to the right side. So I subtract 2x from both sides, which then gives me 2y equals negative 2x plus 4. Now, y is being multiplied by 2. So to get rid of it, we need to divide all things in the equation by 2. And in doing so, I now get y equals negative 1x plus 2. And I will graph this one in pink so we remember. Okay, so now we have two equations, right? We have a linear system in slope-intercept form. So let's put them on the graph. Our first equation, it looks like our y-intercept of the line is at negative 3. So I'm going to go down 3, 1, 2, 3 on the y-axis. Okay, my slope is negative 1 over 1, right? Because that's what's in front of x is our slope, which means I'm going to go down 1 into the right 1. Okie dokie. So I'm going to go down 1 to the right 1, down and right, down and right. Now, we have to do the inverse, so up and left, up and left, up and left, up and left. And then we're going to draw our straight line. Ooh, that one was good. Okay, let's graph our second linear equation. Okay, looks like our y-intercept this time is positive 2. So I'm going to go up 2 on the y-axis, but my slope is still negative 1 over 1. So I'm going to go down 1 into the right 1. And then I'm going to do the inverse, so I'm going to go up 1 into the left 1. And then we draw our line. Now, again, our lines are parallel, so they do not intercept, and there is no solution. Now, let's solve by elimination again. So let's rewrite the linear system. We got 2x plus 2y equals negative 6, and then we have 2x plus 2y equals 4. Now again, when you have the same coefficient, you're going to subtract. So I subtract, but when I subtract, that cancels x and y. So this is no solution. All right, let's flip to the next page. All right, so now we are going to do linear system with infinitely many solutions, right? So we just got done doing a linear system with parallel lines. Now we're going to do one parallel line, sorry, with no solution. Now we're going to do the same line that has infinitely many solutions. So, a linear system has infinitely many solutions when the graphs of the equation are, what do you think? Did you guess the same? You would be correct. Let's put R, the same line. A linear system with infinitely many solutions is called a consistent dependent system. So consistent dependent system. Now sometimes you will just see consistent system, you won't see consistent dependent, and that's fine. So, oopsies, forgot an S. See, this is why I teach math, right? Okay, hold on. Well, now that looks funky. Consistent. There we go, that's much better. So, consistent dependent system, and sometimes you will just see it being written as consistent system. So let's practice 2. All right, we have 2 linear systems, right? We have our linear equations. We have x minus 2y equals negative 4, and we have y equals 1/2 x plus 2. Now, lucky for us, one of these is already in y-intercept form, or slope-intercept form, but this one's not. So we're going to have to put it in slope-intercept form, right? So in order to do so, we are going to have to move that x to the right side of the equal sign, right? Because right now it's on the left, we need to boot it to the right. So the inverse of positive x is negative x. So you're going to subtract x from both sides. So now you should have negative 2y equals negative x minus 4. And to get y by itself, I'm going to have to divide by 2 in all the terms in my equation, which then gives me y equals 1/2, because remember, a negative divided by a negative is a positive, plus 2, because again, negative divided by negative, positive. So if we take a looky here, this slope-intercept equation is the same as this. So let's graph it. We said that our y-intercept was at positive 2, and that our slope was 1/2. And if we have a slope of 1/2, that means we're going to go up 1 and to the right 2, because we need a positive line. So let's go up 1 to the right 2, up 1 to the right 2, and then we have to do the inverse, so we're going to go down 1 and to the left 2. Now, here's the thing. They are the exact same line. So what I'm going to do to show that is I'm going to put 2 arrows, so that way you know there's kind of a line on top of a line, right? They are the exact same line. So if you want to put a little note for yourself, we know that they graph the same line, right? And in this case, it means that the slope is the same and the y-intercept is the same. All right, this wants us to solve by substitution. So it doesn't want us to solve by elimination. It wants us to solve by substitution, right? So let's rewrite our linear system. We have x minus 2y equals negative 4. And then we have y equals 1/2 x plus 2. Now, remember, when we're doing substitution, we need to have one of our linear equations say x equals or y equals. excuse me. And in this case, we already have one, right? Y equals 1/2 x plus 2. So I'm going to use that value, right? And I'm going to plug it in for y. Now, we have to rewrite our equation. So we have x minus 2, parenthesis, 1/2 x plus 2, close your parenthesis, equals -4. Okay, so now let's solve. First things first, I have to distribute, right? Because I have to get rid of those parentheses. So I'm going to multiply -2 by all things inside the parentheses, all the terms. So x stay the same. I have x, now -2, which would be -2 over 1, times 1 over 2 is going to give me -2 over 2 or -1. -1x, and then -2 times 2 is -4, because a negative times a positive is a negative, equals -4. Okay, I need to have my variables on one side and my numbers on the other, right? So let's combine like terms. Well, if I have 1x minus 1, well shoot, I don't have any x now, right? I just have 0. And then if I add 4 to both sides, due to the additive inverse property, I now have 0 equals 0. So that is how you know that you have a system with infinitely many solutions. You should get 0 equaling 0. Now you're probably thinking, well, Miss Maddie, the other one had 0. Okay, but it had 0 equaling a number, right? It had 0 equaling 8. And that's not okay, right? But this one has 0 equaling 0. Now you're probably thinking, I want you to think back when we did, here, I'll try to pull them up. When we did our solving graphing. Okay, so when we look at this lesson, when we did solving by graphing, right? And we needed to see if something was a solution, we would plug that point of intercept in. But we would get a number equals a number, okay? So that's kind of how you can think. When it has a number equaling the same number, that's how you knew it was a solution. When we have 0 equaling 0, you have infinitely many. And then if you have 0 equaling a number, no solution, right? Okay, I want you to do this next one on your own, right, for practice. And then you can check back in with your group, or you can check back in with me for the answers. Okie dokie. First things first is you should have put this first equation into y equals mx plus b, right? And in order to do so, I subtract 2x from both sides. So I now should have 2y equals -2x minus 8. And then you should have divided by 2, which gives you y equals -x minus 4. Lo and behold, your two equations now have the exact same slope and the exact same y-intercept, right? So let's put them on the graph. Our y-intercept is at -4. So I'm going to go down 4 on the y-axis. 1, 2, 3, 4. And my slope is -1 over 1. So I'm going to go down 1 and to the right 1. I do the inverse, so I'm going to go up 1 and to the left 1. Now remember, when I want to show two lines that have the exact same, or they are the exact same line, I'm just going to put 2 arrows. So that way you know there are 2 lines there. Okay, so your graph should have looked something very similar to this graph. Okie dokie. We're now going to solve by substitution. Okay, so we're going to plug in our value, which it looks like would have been -x minus 4 for y. So let's rewrite. We now have 2x plus 2. I'm going to start my parenthesis. Negative x minus 4. I'm going to close my parenthesis. Equals negative 8. Okay, time to distribute. So I'm going to distribute positive 2 to all terms inside the parenthesis. I now have 2x plus 2x minus 8 equals negative 8. I'm going to combine. Whoa. Miss Maddie made an oopsie. I'm so sorry. So you should have had 2 times negative x, which gives you negative 2x. Woo! Okay, so negative 2x plus positive 2 are going to give you 0. And if I add 8 to both sides, I now have 0. So it has infinitely many solutions. All right. Flip to the next page when you are ready. All right, everybody. So now what we're going to do is we're going to take that knowledge that we just had and we're going to put it into work, right? So now we're going to have to take a problem that isn't sometimes always set up, kind of how the other one was. Since we were learning, the other one was pretty much set up for you, right? So when the equations of a linear system are written in slope-intercept form, you can identify the number of solutions of the system by just looking at the slopes and the y-intercept of the line. Okay, I want to repeat it one more time, right? So when the equations of a linear system, so remember linear system, 2 linear equations, when both are written in slope-intercept form, you can identify the number of solutions to the system by looking at the slopes and the y-intercepts of the line. Okay, so here's a little cheat sheet, remember? So number of solutions. If there is one solution, they're going to have different slopes. If there's no solution, right? So that was when you had, 0 equaling a number. They have the same slope, but different y-intercept. And when there's infinitely many, that's when you had 0 equaling 0. And they had the same slope, same y-intercept. Okay? So what we're going to do is we're going to have to put each linear equation into slope-intercept form. And then we're going to use the chart and we're going to see what solutions we have, right? So here we go. Let's do number 1 together. Okay, these are not in in slope-intercept form, right? It looks like they're in standard form. We're going to have to do something about that. So the first equation right here, I have 5x plus y equals negative 2. Okay, I need to move 5x. I got to boot it to the right side. So in order to do that, I need to do the opposite, or write the inverse of positive 5x, which is negative 5x. So those cancel. What I do to one side, I must do to the other. Okay? So my new equation, I'm going to write it down here, is y equals negative 5x minus 2. Okay, that is now in sloped-intercept form, right? Let's do our second equation. So we have negative 10x minus 2y equals 4. Okay, same thing this time. I got to move that negative 10x to the right side of the equal sign. So in order to cancel, the inverse of negative 10x is positive 10x. Those cancel. What I do to one side, I must do to the other side, right? So now I have negative 2y equals 10x plus 4. I'm going to need to divide by -2 to all terms in my equation. I now have y equals -5x minus 2. Okay, so now what you need to do is look. They have the same slope and the same y-intercept. So let's go back up to our chart. Okay, when they had the same slope and same y-intercept, they are infinitely many solutions. So for our answer, you could have just written infinitely many solutions. So that's how you can tell. Okay, let's do another one. So we're going to put both of these equations, right, into slope-intercept form, y equals mx plus b. So it looks like we're going to have to do the same thing to both. We're going to have to subtract 6x to both of them, and then we're going to have to divide by 2, right? So let's do the first one. I'll do the first one in red. So I have 6x plus 2y equals 3. I'm going to subtract 6x from both sides to keep my equation balanced. I now have 2y equals -6x plus 3. And I'm going to divide by 2 in all terms, which now gives me y equals -3x plus 3 over 2. Okay, let's put our second linear equation into slope-intercept form. So I'm going to rewrite it over here. I have 6x plus 2y equals -5. I'm going to do the same thing. I need to move that positive 6x to the right side, so I'm going to subtract on both sides. I now have 2y equals -6x equals -5. I divide by 2. I now get y equals -3x minus, oopsies, why did I write an equal sign here? 5 over 2. Okay, so now I'm going to look. They have the same slope, but it looks like they have different y-intercepts. So if I go up here, if they have the same slope but different y-intercepts, it is no solution. So number 2 has no solution. All right, down here, I'm going to do the same thing. I'm going to put both of those equations into slope-intercept form. So first equation, I'm going to rewrite x minus 3y equals -15. I need to subtract x from both sides. I now get -3y equals -x minus 15. And you must divide by -3 to all terms in your equation, which gives you positive y. A negative divided by a negative is a positive. Negative divided by a negative, positive. So for our first one, we have y equals 1/3 x plus 5. Okay, let's do the second one. We have 2x minus 3y equals -18. I'm going to subtract 2x from both sides of my equal sign. I now get -3y equals -2x minus 18. To isolate my y, I need to divide by 3 in all terms. So now I get y equals positive 2 over 3x plus 6. Okay, so let's see. For the first equation, my slope is 1 over 3. My second one is 2 over 3. For my first equation, my y-intercept was 5. And my second one, my y-intercept was 6. So they have different slopes, right? So then this one, number 3, the answer would be 1 solution. Alrighty, I want you to do 4, 5, and 6 by yourself or with your group. And then you can check back in. So I want you to do 4, 5, and 6 by yourself. And then you can check in with your group or you can check in with me. And this is the end. This is the last page of our lesson, right? So we are done with 7.1 through 7.5. We are done with the systems of equations unit.